Good afternoon. Can you hear me all? Good. Thank you. Thanks for being in the most important session in this TechEd. If you have gone to others and if you're going to the others, I don't know, but this is the most important one because this is customers talking to customers about customer deployment. This is for the customer, by the customer, and of the customers. And what we have here is 5 of the best customers talking about their always on deployments. Always on is the flagship HA and DR technology we released in SQL Server 2012. We are enhancing them in SQL Server 2014. And so what we are coming up with is what this customer has gone and deployed, what lessons they have learned, what are the best practices they recommend. Each one of these presentations is actually a full session in itself, each of these customer stories. But we have not had it, we actually compress them into one to give the best combined value to you. We'll be sticking around after the presentation here. We'll be in the booth area, so please come and ask questions because we know you'll have tons of questions. And if you ever wanted to pick the brain of the best in the HA and DR involving SQL Server and everything in between, operating system, network, everything, whatever is needed to have your HA and DR for your application, you would not have got a better set of brains to pick. So I'm extremely proud to bring this set of customers to you. I talk for a couple of minutes, then hand it over to them. It's all about them. So let's set the stage. We assume that you know a few things before this. We will not go into the fundamentals of these things here, but if you have those questions, we'll be happy to take them on afterwards. We'll be happy to take them on in the booth. And those are we understand that you know a bit about always on failover cluster instances. You know a bit about always on availability groups. And you know a bit about Windows Server failover clustering. If you don't know the details, if you don't know the depth, don't worry. We can answer them questions as we go or afterwards. But we expect that you know this a bit of fundamental because these complete HADR models are built on top of this. And how many of you think that always on is equal to availability groups? I'm glad because it is not. What is always on? Always on is a brand name used for 2 features in one set, and they include the failover cluster instances, the shared storage model that we have been used from before. It has been rebranded under always on umbrella, and the new availability groups introduced in SQL Server 2012. They're all called always on. So if you're saying that I'm using always on, you could be using one of these 2 or you could be using a combined of these 2. And availability groups is not equal to database mirroring. Database mirroring has been there since SQL Server 2005. It is still there. It has been announced deprecated. That means it will stick around for a couple of releases, then it will go away. No further enhancements. But going forward, availability groups is the story for the customer who have been using database mirroring. So we have 5 customers today, and they will come in this order. As I mentioned that each of these deployments, each of these customer stories is a full session by itself, but we will be touching upon some key points from these sessions. They have been using always on failover cluster, multi-site failover cluster. Some of them have been using pure availability groups going across subnets, going across sites. Some of them using combined failover cluster instances and availability groups. Some of them have been using on Hyper-V virtual machines. So you will see a different flavor of the story in each of these customer deployments. You will get the recording of this session. You will get all the slides in your TechEd package or when you go to channel 9. So don't need to worry about taking a snapshot or anything. But if you want, just feel free. Okay, this is just to emphasize that if you can hold on to each of them will talk about around 10 to 12 minutes. If you can hold on to your questions till the end, that will be the best. But if a question is so burning that you have to ask right away, we will try to take one question per each of these sections. If you are asking question at the end, please remember which customer was it associated with so that they can answer it to the best. If you have a question to all of them, feel free to do that way as well. Without much ado, I hand it over to SNet, Mike Steinecke.
Thanks, Sanjay. How's everybody doing this afternoon? Okay, so EdgeNet is a provider of software and services in the retail industry, and we help retailers engage their customers and have solutions that they can use to sell products to their customers easier. All of these solutions are based on a lot of data. So we have a number of these that we work as, we have a software as a service, and we host those for retailers. So we need to make sure that we have high availability in our databases and also have disaster recovery for these mission critical systems for selling. The uptime we have on most of these selling solutions is a 99.9% SLA. So it's not as high as some of the other solutions that are here, especially in the healthcare arena where there's higher tier applications that just cannot go down. But we do need to have applications that provide disaster recovery. My implementation is a little different than most of the other folks up here, where our applications are using Microsoft Distributed Transaction Coordinator. And when using MSDTC, you need to be using a Windows failover cluster and in a SQL Server failover cluster instance. Availability groups are not supported with MSDTC. Our hardware is a rather big platform. We run large core Windows servers running on a SAN backend, and we're utilizing EMC's recover point to do disk-based replication from our primary to disaster recovery site. It'll advance here. So our primary site is in Milwaukee, Wisconsin. We have a Windows failover cluster node A, and we have our secondary site is in Atlanta, which is our DR site. And we're utilizing a feature that was introduced with SQL Server 2012 AlwaysOn in the ability to do a cross-subnet failover cluster instance. So previously to SQL Server 2012, you had to stretch a VLAN between your data centers to do a failover cluster. It's much easier to do that now and be able to do a routed network. So we have asynchronous SAN replication that's happening from these recover point appliances from that Milwaukee site to the Atlanta site. And those sites are about 850 miles apart, so it's definitely quite a distance between them. Although the system is asynchronous, even under load, because we have a fairly fast pipe between those connections, the system's usually about 10 to 15 seconds out of synchronization. So the window for data loss is still very low if you would actually have a disaster that the first site would be lost. As you can see from the diagram, those sites are connected with a 300 megabit connection. So that's what's facilitating that. So the hardware LUNs are on the bottom here, and you see that those are replicated across to the other side. So from the SQL Server instance, it just looks like there's one set of disk. The block-based replication abstracts all of that from the server. So it just looks like a local failover cluster instance. We are also using availability groups at our primary site to offload work off the primary server for reporting services. So we're actually using a combination of a failover cluster instance across sites and then an availability group locally to provide offloading from the main server. So we have a 3-node Windows Server failover cluster instance. 2 nodes at one data center, 1 node at the other. There are 4 SQL instances and 1 clustered MSDTC in this configuration. So when the SQL instances fail, we also fail the MSDTC with those. We have about 12 terabytes of SAN we're replicating and quite a number of LUNs with this system with 54. And we're also utilizing one of the other new features in SQL 2012 by putting tempdb on local disk. When you're replicating that data from one site to another, there's cost associated with that. Every time SQL Server starts, it recreates tempdb. So there's no reason to replicate that tempdb from my primary site to the other site, especially with tempdb, which can be very volatile. Saves money on storage replication and licensing. And we're also able to use solid-state disk or local disk for that tempdb, so we can also increase performance of that tempdb on those local servers, where all the rest of the data is being stored in the SAN. So some deployment considerations with this. the SQL Server stack is only part of the story in doing any HADR configuration. You need to make sure that your clients can also connect to that SQL Server. Otherwise, just because the server is running, if the clients can't connect, what use is it? There are some specific enhancements that were done in the SQL driver stack to help support this. When you create a failover cluster instance or an availability group in a multi-subnet cluster, when the SQL Server installer does something called register all providers. And what that does is it takes and registers both IP addresses, one from each subnet, in DNS. So when your client goes and connects to this, it gets back both addresses. And then the client knows that the one that responds is the one to talk to. So during a failure, the client already has both of those IP addresses resolved and can start talking to the server as soon as it comes back up at the other site. One thing to also keep in mind in doing distance cluster installations is make sure that you have enough time planned both for installations and also for doing updates to your systems. Network latency between those two servers doing your installations greatly impacts the install time. With SQL Server 2012, that time has been reduced greatly, but it's still a consideration. You also want to make sure, because you have the same problems in doing service packs and cumulative updates, that latency between those cluster nodes comes into account. When you do your initial installation, you want to slipstream your SQL install with the latest patch level of what you really want to be using. That'll greatly simplify your installation process. Let's see. Particularly one of the updates that was in CU1 of SQL Server 2012 fixed our installation problem. Because we have between 50 and 75 LUNs in our configuration, it took hours to do the CU until this patch was put in. So you really want to make sure that you run the latest version. So now, if anybody has one question or anything, I'll hand it over to David from Service U. You there, or?
I was just wondering about whether you're using asymmetric storage, because when you're doing the clustering, how is the storage getting recognized on the far side?
So in my configuration, the storage is replicated by the SAN. So the storage is technically asymmetric, but it's not the same storage on each side. But to SQL Server, it looks like symmetrical storage.
So in your Windows cluster configuration, would you be able to see the drives on the far side, or you'll see it when you flip to the far side?
So there are one set of drives that show in Failover Cluster Manager for disk resources. Whichever side is the active side can see the disk. Okay? You follow on to that?
So instead of using clustering, why didn't you virtualize this and use the virtual infrastructure to fail the instance over?
So the question is, why don't we just virtualize SQL Server on this? And this solution was actually first built on Windows Server 2008 R2, and we couldn't virtualize the SQL Server large enough under that platform. Now we could virtualize the SQL Server under Server 2012, but we still have the problem where we need to replicate that disk to the DR site. So we still have to replicate that to the DR site somehow, and it would be the same way. I could virtualize this server under Server 2012, Hyper-V, but I'd still need to replicate the SQL disk to the distant side. The Hyper-V replica would have too much potential for data loss.
Yeah, no, I was just looking at the disk, but instead of clustering SQL Server, instead of using a SQL Server cluster, why you just didn't put it on a virtual and use the virtual to fail that SQL Server instance over to the other side? In other words, just move it over even though the storage is all replicated underneath it.
Could look at something like that as well, I guess. That's just not the solution we picked. So the question is if we have any requirements for transparent data encryption in our configuration. We don't in our configuration, but we could utilize that within SQL Server. We just need to turn on data encryption on the tables that would need that. It wouldn't change the architecture of it at all. So when you say AlwaysOn in that configuration, you're referring to availability groups, which are 2 separate servers and 2 separate SQL instances. Okay. Yes, you can use transparent. You can use transparent data encryption with a SQL failover cluster instance because it is the same instance. And somebody else is going to talk about that up here. So, okay. So here's David from Active Network Service U.
Thank you. All right. So my name is David Smith. I'm a Senior Director of Enterprise Architecture at Active Network. Active Network is a cloud-based SaaS provider. We provide event management systems, registration systems for basically anything that you might be involved in with your family or sports, hobbies across the U.S. and across the world. So today what I'm going to do is I'm going to talk you through a couple of scenarios regarding clustering as you move into SQL Server 2012 and availability groups, and talk to you about some details that you need to understand as you go through and implement this in your own environment. So typically what we have is most people probably have some experience with database mirroring, a cluster at each site and multiple sites. Let me see a show of hands of how many people have implemented that or are familiar with that architecture. Okay, very good. So most people are familiar with this. You have, like I said, 2 different SQL Server failover cluster instances. You have 2 different Windows Server failover clusters, 1 at each site, and then you have a pipe in between where you're mirroring your data. The key is that as you move to SQL 2012 and an FCI plus AG configuration with failover cluster instances and an availability group, what you do is you move to a single cluster that spans both sites. And there are some very important considerations that you need to take into account as you develop that architecture. So that's what I'm going to talk through here briefly. First, let's look at a single subnet configuration. The simple configuration, if we take one of your 2 sites, what are the things that you need to be thinking about and how does it actually work? What you see here are 3 nodes. You may have 2 nodes in your environment, but 3 nodes, you have a public network, public subnet, and then you have a private network with a separate subnet. The 2 key operative items that you need to consider when you're setting up a cluster are resiliency and quality of service. Resiliency means that even if there's a network failure or some type of failure between nodes, the cluster needs to communicate with the other nodes. So ideally, you're going to have multiple paths. Quality of service means that of all the traffic that's happening on those servers, the cluster communications need to have priority over everything else to again ensure that the cluster always knows its status. The communication happens within the same subnet. So within the public subnet, you're going to have communication. You're going to have separate communication between the private subnet in a single subnet cluster. The heartbeats, though, happen on all interfaces. It's a misconception that the heartbeats between nodes only happen on the cluster communication network. That's not the case. The heartbeats actually happen on all interfaces. There is a setting within Windows Server, and this goes back several versions, for plumb all cross-subnet routes. The reason for that is to discover valid routes that may exist between your public and your private networks or between different subnets. So for example, I said that the communication will typically only happen between the same subnet. We may have, between these 2, we may have a backup network. We may have a router that spans the public and the private networks. And if so, there's a valid communication path there. We have the option to set one of the cluster properties to plumb all cross-subnet routes, set it to 1, the default is 0, set it to 1, and by setting it to 1, we tell the cluster, try to communicate between one subnet and other subnets. That gives us the ability to discover valid routes and increase our resiliency within the cluster. Most of you probably have never used that, and that's fine. It doesn't apply in most cases, but it is going to be applicable as we move through the slides here in just a moment. Now, if we turned it on and you don't have a valid route, it means that there would be communication attempted between the public and the private network, and in most of your networks that would fail. Every time it fails, it increases the failure rate and adds towards the threshold of failing over your cluster. So you don't want to turn it on unless you have a valid route. Now, as we move into a single cluster that spans multiple sites, what we have is a little different scenario. We typically, with database mirroring, we would have that single connectivity point on the front end between the public networks in most environments. But here we actually have 4 different subnets. A true multi-subnet cluster is a cluster where one or more nodes have different subnets than the other nodes. So if we have just one single node sitting in the same data center, but it has a different subnet as part of the cluster, you would have a multi-subnet cluster. In this case, what we have are 2 data centers, 2 sites, where the public networks are different subnets, the private networks are different subnets, so we have a total of 4 different subnets. We have a multi-subnet cluster. The problem is we don't have any communication between the private networks. As long as there's not communication between the private networks, we're going to have some failures as it tries to communicate. So there are 3 different ways that you can eliminate this. You can go down to a single NIC, avoid the private network altogether, remove it. If you want to add a little bit more resiliency, you could add NIC teaming, and therefore you have 2 different front-end NICs to communicate. Or you could establish communication across sites for the different private subnets, or the private networks. The problem is that if you don't establish this, you can install it, and here's one of the gotchas. You can install it. You can install this cluster, you can set it up, and it's going to work perfectly fine. Except that every time communication is attempted and it fails, you're adding to the threshold to fail over your cluster. And if you have PCI compliance or another compliance that requires you to log all of your traffic, you're logging every single one of these failures on your networking equipment. And even though it's just a small ping and it's a small traffic pattern, the log file is the same as any other traffic. So you can be developing hundreds of gigs of logs just by logging these failures. So options 1 and 2, you lose resiliency because you remove the private network, but we solve the problem, not the best solution. And even if you do that, you still have to ensure quality of service. Remember I said quality of service is one of the 2 pillars of clustering, in that you need to make sure that the cluster communication can always happen over every other traffic. So the third option is, like I said, to create connectivity between the private networks. So if we create a VPN tunnel, we create a point-to-point tunnel, something like that between the networks. Now we're able to communicate on the private networks between different subnets, with a caveat that the nodes don't know, the servers don't know how to communicate with those networks. We have to create a static route. As soon as that server that has a gateway on the public network tries to communicate to the remote network, it's going to say, I don't know about that network, therefore go out the public gateway. So it's going to go out the public interface to try to get to the private interface. Therefore, on every single node, we have to go and we have to create a static route saying, to communicate with the opposite side, here's how you communicate. So we've added complexity, but there's still a problem. In a true multi-subnet cluster, remember I haven't changed anything about plumb all cross-subnet routes, right? I said that for a single subnet, communication is going to happen between the same subnets. So what happens in a multi-subnet cluster? You have to communicate between disparate subnets. So what happens is, no matter what the setting is for plumb all cross-subnet routes with Windows Server 2008 R2 or below, it's always going to attempt communication from every node to every other node on every interface. There's no way you can turn that off because it has to do that to discover the valid routes between the clusters at the opposite site. It's a feature, and it's a needed feature, but what it means is that in our configuration right here, we still have a problem. We've developed communication between the private networks, but we don't have communication between the public network and the private network and the private network and the public network. Since communication is going to be attempted between all nodes and all interfaces, we actually have to have communication in a star topology to make that work. So the star topology solves the problem. We could create our topology like this. There's no security issue. We're talking about pings back and forth. We're talking about communication within a SQL server. We're not going around a firewall. So we could create this. It provides us additional resiliency, and we have to create 2 more static routes on every node. So obviously, this is creating a significant amount of complexity. It's more difficult to maintain. But if you're using Windows Server 2008 R2 or below with SQL Server 2012 and a failover cluster instance with availability groups, this is the communication that you need to establish between sites. Now, there is a much simpler solution, which is to use Windows Server 2012. And you'll hear very frequently that there's a perfect marriage between Windows Server 2012 and SQL Server 2012. This is one of those cases. With Windows Server 2012, if we go back to our original diagram, we take our database mirroring infrastructure where we had the single communication between the public networks. We were okay with that scenario, right? We had local high availability. We had our cluster. We had our public network and private network. We had a resiliency or quality of service. Everything could fail back and forth. We were fully protected within our local network. And then at the remote network, we were also fully protected. And we had a single pipe pushing data between sites. This is very similar in that we're doing it with a cluster spanned across sites. So we have the option to set plumb all cross-subnet routes to a new value of 2 in Windows Server 2012. The value of 2 means attempt communication between all nodes, between every node and every other node on all networks, but use the first one that actually works. So if we only have one path between sites, like we do here, between the public networks, it'll attempt communication on all of them, but as soon as it finds a valid path between sites, it will no longer attempt the others. You won't have the logs. You won't have the failures that are going to cause a threshold and possibly a failover. It'll just seamlessly work from that point on. So that does provide the local resiliency and quality of service at each site. It's simple, and it's probably what you need for a DR solution. The other thing that I'm going to talk about very briefly is minimizing downtime during migration. I'm going to go over this pretty quickly just to provide you some context, and then afterwards I'll be more than happy to discuss it in a lot of detail. The first thing I'll say as you move forward into this is that it is a shift. It's a paradigm shift. It's not just an upgrade. You need to rethink your strategy. You need to rethink your run book. You need to do a lot of testing and make sure that you fully understand the scenarios before you go live. It's not a new version of database mirroring, as Sanjay said. It's a new technology, and there are new rules, and there are new things that you need to take into account. So test very thoroughly. In the case of doing an upgrade, if you want to do a simple upgrade with minimal downtime, one way to do that with your current database mirroring topology is keep your database mirroring in place between sites, set up a temporary server locally, set up log shipping between your primary site and that new server. The new server is SQL Server 2012, and just walk away. Go home for the weekend, enjoy it, come back. Whenever you're ready to do the upgrade, what you do is you first remove database mirroring to the remote site. So you have now just log shipping to your SQL 2012 instance. Stop log shipping, turn on database mirroring, all the data's there, it instantly comes on, starts working. And then when you're ready to do the upgrade, you just simply do a failover, and now SQL 2012 is your primary instance. The other thing, or another thing that you want to do is always use DNS aliases to abstract your connection strings. If you do this with your application before you do an upgrade, nothing changes with your application. It's still connecting to the same DNS alias. You just go into DNS and you point it from old cluster to new cluster, reboot maybe to remove any connection pooling, and you're back up and running. During the database upgrade, as you fail over, when you first fail over to SQL Server 2012, or you do a restore, the very first thing that will happen is a metadata operation on the databases to convert the database version itself to the latest version. That's something that you need to take into account when you plan for minimal downtime. It will take some time. It's generally based on your I/O, not on CPU or memory. So whatever your I/O is, that's going to affect how quickly you're able to get through that. So if you're able to take some non-critical databases, maybe for internal systems that are only used periodically, Fail those over first, let them do the upgrade before you actually take downtime. That'll decrease your downtime. And then involve multiple people. You're going to need lots of people involved as you do the upgrade, especially, like I said, it's a paradigm shift. Get your networking team involved, get your clustering team, your database administrators, your application team. Get everyone on the same page and ready to do the upgrade. In our case, we were able to upgrade from SQL Server 2008 R2 or 2008 to 2012 in less than 3 minutes downtime, total downtime. And we did that with extensive testing by doing scripts ahead of time to make sure that we were able to run through those tests. So you can do this in a very minimal amount of time and do it very effectively. All right, so next we have Care Group to talk about their implementation.
Can you hear me now? Yeah. My name is Ayad Shamout. I'm from Care Group Healthcare Systems, and today I'll share with you also our AlwaysOn high availability SQL Server setup and the current environment production and the new coming soon. So quickly about Care Group, I'm not going to go over the details. The only call out I would say we've been ranked #1 as the most innovative IT department nationwide. So that's due to we are using the latest and greatest technology. Different technology supporting different clinical applications. So, and also we have a case study on Microsoft website if you want to read more about our use cases. This is the environment. Again, I have a few slides talk more about the existing design. The way for us to maximize our investment and manage the environment efficiently is we group the database as their classification. So we have 3 classifications, AAA, AA, and 1A. AAA being is 24/7, mission critical environment, 0 downtime, 0 data loss. And those kind of clinical or patient systems that we can go down for any reason. So that's where we invest heavily with the technology, the hardware, the software to make sure we meet our SLA. AA is kind of a little bit relaxed environment, so we still manage 24/7, but we can go down for an hour or so. And 1A is kind of the not low end, but it's less critical type of database. We started virtualizing SQL Server about a couple of years ago, and we decided to use Hyper-V, Windows Server Hyper-V. How many of you using SQL on Hyper-V or VMware in general? Okay. Hyper-V? Okay. So what we discussed today is the Hyper-V implementation, which is kind of close to VMware, but it's a different flavor of the technology. So quick review about the hardware. The only thing I want to focus is we created dedicated network connection for different option or feature in the Hyper-V and the cluster environment. So as you see, we have a cluster management connection. We have a private 1 and private 2 connection, dedicated connections. Live migration, I'm going to share with you why we decided to choose the Hyper-V technology and how live migration help us to meet our SLA requirement. So this is the, now better. So this is the existing environment. It's in production. We run in Windows 2008 R2 SP1 operating system. So the top part represents our primary instance, my primary site, and the bottom part is the DR. So first thing we did is we introduced 2 hosts, Windows 2008 R2, and clustered the 2 hosts together so we can take advantage of the live migration. And that's where we have the first Windows cluster between the host node A and B, and those represented the platform for the Hyper-V environment. Then that's with the first cluster, we have a protection for hardware and OS failure. So if we lose one node, all the VMs will fail over to the other node, and if we lose operating system or hardware failure, we are still protected. The second cluster we presented in this environment is the guest cluster. So So for AlwaysOn, it requires the SQL instances participate in the AlwaysOn to be in one Windows cluster. So we have the two sites, and we have one cluster span the two sites with the 3 nodes participated in the cluster. So we have Denali, A, B, and C instances in one Windows cluster. So we have now 2 clusters integrated in one environment, and that's provided us or protected us from SQL failure and OS failure as well. So if we lose the host, the VM on one host, we have the failover capability on the other instance of SQL Server. So that's number 2. Number 3, now we introduce the availability group. With availability group, I can group one database or multiple databases as one group, that when I initiate a failover, I fail over all those multiple databases as one availability group altogether. So that's where we have the patient billing system. We have the primary instance on the left side, which is Denali A, and having 2 secondaries set up on Denali B and C. So we also did, because of the 2 first node, A and B, are on in the primary side, so network connection is very, very fast. So we set up those as synchronous connection. Where the third node is on our DR side, so we still have a fast network connection, but we decided to use asynchronous, so it doesn't really impact the performance on the application. So this is today's production environment, and we've been running SQL 2012 on Hyper-V Windows 2008 R2. Okay, so the reason I said why we use Hyper-V is to take advantage of live migration. I will share with you how live migration works, and we tested this without losing a second connection to our application, to our SQL Server in this case. So we have the client connected to the Denali on the left, and as I said, with the Hyper-V, just to give you a background, we still have the host, 2 hosts, node A and B, and I have a shared storage. For Hyper-V, there's something which is the cluster shared volume. So the disks are connected and presented to both hosts in the cluster. So that means I have both servers connected and access the storage at any time. Then I created the VMs, which is Denali A on the left, and I have a second VM on the right called Denali B, with an always-on connection between them. So if I lose the database or I decided to fail over, the database on the Denali A will be failed over to Denali B. But in this case, I want to really do a maintenance on the first node. On the left side, I want to take it down for maintenance, or I want to apply service pack or anything. So because I don't want to lose the availability of SQL, in this case, Denali A VM, I want to initiate a live migration. With live migration, will allow me to take the whole VM from the host on the left, move it to the right, without losing connection between the SQL instance and the application. So with live migration, how it works, first thing it does, it copies the configuration data from the VM on the left and prepare the placeholder kind of in the host on the right side. So what's that done now? Still the application connect to Denali on the left, but it's preparing the new VM to be live to be migrated to the right node. So first thing, copy the configuration data. Second, it will copy the memory. So everything in the memory on the node A will be copied to the new VM on the right side. And once the memory copied, it will go through a memory sync process, make sure that everything on the left node sync with the right node. Keep in mind, SQL still writing to the same storage that the other nodes still see. So that's why there is no physical disk failover when I do the live migration. So now once that's done, last part is going to go switch the connection of the client redirected to connect to the VM on the right side. We tested this and actually works perfect with no connectivity loss. And the application was up and running during the live migration. This is actually, it's in test, not in production, but a lot of time, every 2-3 years, we go through an upgrade process, either operating system upgrade or hardware upgrade. And in the past, we used to take advantage of database mirroring, where we can have SQL instance on the production, and we prepare the new environment on the latest Windows operating system, or it's a new hardware, using database mirroring so we can sync the databases, and then we decide to fail over, and the new hardware become our production server. But with AlwaysOn, there is a limitation that I can't really mix operating systems, or I can't mix different cluster in order for me to do the live migration. So in our scenario, current production is Windows 2008 R2 with AlwaysOn VMs sits on the host on the left side. But we want to really move to Windows 2012 operating system on a new hardware or on a different hardware. So in order to do this, Microsoft SQL Server 2012 SP1, and Microsoft introduced actually a new feature in SQL 2012 SP1 that will allow us to connect two different clusters together to do the AlwaysOn, and then you can do the switch or the failover in a way to the right side. So the way we did it, as I said, then the left side is the current environment. We introduced a new 2 VMs with Windows 2012 cluster, and both on the right side is SQL 2012 SP1. So on the left, as you see, it doesn't matter if it's SP1 or the RTM, it still works. But the right or the new nodes or the new instances of SQL has to be SP1 installed, because that's new features in SP1. So first thing we do is just to give you a definition of HADR, cluster context. This is a feature where the cluster instance determines which cluster manage the availability replica. So that means on the left side, because that's my primary, that's my production, then Windows 2008 R2 is my cluster context manager. So that's how I manage all my replica on that instance. So for the two instances, in order to be part of this new cluster environment, in order to create AlwaysOn or add them as a new two replicas, I have to do first thing, I have to switch node 3 and 4, which are 2008 R2 SP1, switch to the 2008 R2 context, so cluster context. So there's a command line, it's a T-SQL, that you can do that switch. So SQL Server SP1, node 3 and 4, now it's kind of listening or following the direction of the 2008 R2 cluster, which manage the metadata for the replicas. So having that done, then now I would be able to set an availability group and install the new two nodes, 3 and 4, as a new replica to my existing availability group on the left side. So this is where now it will allow me to set up, and just one thing to mention here, if I have in my production 4 replicas, because that's the limit, in order to do the migration, I have to delete 2 replicas and introduce 2 new replicas and the new cluster so I can do the migration. So number 2 is now I'm connected to the primary. I added the 2 nodes as the 2 new replicas. When that's done, it's going to do the data synchronization. So number 3, I can go ahead and delete the listener. Listener is in AlwaysOn is the virtual network name, so the application uses that virtual network name to connect to my availability group. So when I do failover from one node to another, it doesn't matter where my database are live, so it is really still connected to that virtual network name. But because now I want to switch that virtual network name to the new cluster, so first thing I have to do is I have to delete that the listener, which is the virtual network name. Number 2 is I have to take my availability group offline. So now this is the true downtime, means the database or the application will be down until I bring the availability group and create the AJ listener on the new cluster. And here we're talking a minute to 2, not too long. So that's kind of a planned downtime. So now once I do that, now last piece I would do here is I switch the cluster context back to the local cluster. So remember first, number 1, we had the node 3 and 4 cluster context switched to Windows 2008 R2. Now I will switch it back, which means I'm telling Windows 2012 cluster is going to manage my availability replica. So once I do this, it will allow me to switch the primary role now to the node 3, becomes my primary replica. and I will go ahead and create the AG, the availability group for the database, and also will create the AG listener. One thing you have to keep in mind, in order for the application to reconnect without change connections, you have to maintain the same availability group name and the same listener name. So in this example, I used AG1, which was the same before, and also AG1_listener. So that's very important. Otherwise, if you decide to change them, you have to change the connection for the application to point to the new cluster. So this will allow you now to fully migrate from Windows 2008 R2 cluster environment to the new Windows 2012 cluster with a very minimal downtime. And then you can just retire the environment in the left. Okay, sorry, I'm running out of time. Quick thing to share with you is we run into an AG listener issue. As I said, AG listener is the VNN, the virtual network name. And in order for the application to connect seamlessly, we can fail over between nodes without any interruption. But we run into a problem, and the problem is it's actually it's between Windows operating system and an antivirus software. And it's a Windows-related problem, something to do with the Windows TDI, the transport driver interface, which is how to manage the network communications. So if we use the multi-subnet feature and allow all IP registered in the DNS, so when you create the AG listener, it will register the two IP addresses of the two replicas, the primary and the secondary. So that means I have two active IP addresses registered in DNS. If I lose one with a failover, I can connect. In our case, we couldn't really connect because of the antivirus was using the TDI, and Microsoft recommended not to use that TDI driver. So because of that problem, we lost connection completely. We have to manually unregister one IP and register the new IP. So just to be, these slides will be available. So the symptoms, the issue, we found the workaround by setting one IP to be active in DNS. And when we do the failover, we have to unregister that IP address, register the new IP address, then the application reconnect to the new instance. But that's, again, will be about a minute to 2 minutes outage. And with that, I'll pass the mic to Bwin. Thanks. No.
One, two, three. Yeah, okay. Sounds better now. The bad thing about being the fifth one in the row is that I should actually already be finished, so I'll try to be quick. And sorry, I'm not an American, so my English might suck a little. Quick overview. The system I'm talking about is a real money handling system. Bwin Party is an online gaming company, so we have a lot of money coming in. It's the authoritative system for us that runs responsible gaming limitations. So every country has its own limits on where you can gamble, how much you can gamble, stuff like that. So the system that we have is responsible for holding that data. So it's a highly important system for us, and includes a special data warehouse to run the reports on that. We're talking multiple databases in multiple availability groups. So I will always focus on one. It's just similar for everything else. Just so you're aware, this is an active system. We are running more than one database on that. And we have 4 servers in the topology. I'll show you the diagram a little later on. Okay, what our objectives are? We try to keep 99.99% availability, and we normally keep that. And as with systems like David's, this also includes maintenances. So in our system, we can't allow to go down for a maintenance as well. There might not be lives hanging on it, but it's money hanging on it, which is pretty much the same as a life nowadays. The key part for us is recovery point objective is always 0 data loss. And this includes the worst case scenario of losing a complete data center. This is what sets us apart from pretty much every other solution you've seen so far. If I lose a data center, I'm not allowed to lose any data. I'm not a bank. They obviously are allowed for that. And I have to be online 10 seconds after the data center goes down. So the solution needs to be completely automated. And the last point for that is, even if one data center is down, I must still be able to do maintenance on the servers. Oh yeah, and the data warehouse is not included in that. So how does the system look like? As I already said, we have 4 servers in that, which is not entirely true because you can see there's a 5th server. We actually use 3 data centers to do that, the 2 main data centers and 1 for the witness. We do have a sync replica between those 2 data centers, which is also the auto failover partner here. So when one server, this primary, goes down, we actually switch to another data center. Then we keep another async replica here for the data warehouse, which does read offloading. And we have a second sync replica, so just in case this one fails, that we can quickly reestablish an auto failover partner. This 4th replica is also used for backup offloading in most of the cases. Just to give you a little perspective on how this looks like when you look at all availability groups, we have the primary replica, which is the green points here, switched between 3 of the 4 servers. The only server that does not have a primary replica of a database is the data warehouse. The secondary is always the one, it's the yellow one. Auto failover secondary is always one that is in the different data center. And then we have the other one for backup offloading. The key setup points in our system, we use a quorum model of node and file share majority, which means every server in this topology has a vote. And the file share is the tiebreaker in case we lose connectivity between the data centers. To do this, you need 3 locations, because obviously if you only have 2, if the wrong one goes down, you lose your quorum. Or in a worst case, if you configure it wrong, you lose any of those 2 and you're down anyway. So not good. And as I already mentioned, we want to avoid downtime even if a data center goes down. So we do automatic failover between those 2 data centers. You have heard a lot of those migration considerations already from my colleagues. Just want to emphasize a few of those. It's in database mirroring in the past, it was a very easy process. You had the DBA and the DBA only, and if your network guys have opened the firewall correctly, then everything is fine and you can just do this by yourself. This is not the case anymore. We are now including Windows failover cluster, which means we have an Active Directory behind this. We use DNS a lot. So you have the Windows guys, you have cluster guys, you have DNS guys. There's a lot of people involved to do that. You have to coordinate those right, otherwise you will be in big trouble. And if you're a small shop and you don't have experts on all these fields, well, then your DBA is out of luck and he needs to become an expert in very, very many fields to run this. You need to change your connection string if you had mirroring before. How many of you did use database mirroring? Okay, so some of them. You might know that if you connect to a mirror database, you have to specify a server and then a failover partner with the other server. You don't do this anymore, and this only works when you have one replica. Nowadays, you use the AG listener, so you need to remove the failover partner connection string from your systems. Or as we do it in our case, we keep it in there just for migration purposes. Because other than Ayat explained before, I do not like the way of taking everything down for migrating it to a new operating system. We switch back to database mirroring to do that. Ayat already mentioned this. Before you could have different OS versions. This is no longer possible, which is a pain right now, and I certainly hope that we get a solution for that at some point. And of course, now you need everything in the same Active Directory domain, but this is not a SQL thing, this is a Windows cluster thing. Post-migration considerations. Monitoring of availability groups is a lot different than monitoring of mirroring. So whatever you did to monitor mirroring before, forget it, do it again, do it differently. Everything changes once you have availability groups. It's a lot more complex, you have a lot more things that can go wrong that you need to take into consideration. You need smarter DBAs. Availability groups are not easy, that's the key point I want to make. You need people that know what they are doing. You have more components, which means more complexity, which means more troubles in troubleshooting. Because David didn't mention that, but it's actually a problem. Before the system with availability groups, you had no cluster. So everything was in the database alone. Now, if your Windows cluster fails, the database instance might still be there, but your database is offline, and you don't immediately see why unless you look in the Windows cluster as well. A little word on Windows Server 2012 on that. we run this whole thing on Windows 2012 because we think it's an easier solution. Dynamic quorum, so if one node goes down, it takes the vote out. You can do many things a little easier. Cluster-aware updating is something that really helps us to stay compliant because we need to patch pretty often. And if you run backups to a remote file share, RDMA is just a blessing if you have the network infrastructure. The problem, though, is with Windows 2012, getting there is a pain. Ayad already said it. You can't have a cluster across multiple versions of the operating system, so no in-place upgrade. I don't know how many people do use in-place upgrade. I like it in some scenarios, but that's just not possible. And if you use the way that Ayad described, you have to do all availability groups at once. You can't do one after the other. The second thing is, when we migrated to Windows 2012, we had some incompatibilities to face. There are some features that just don't work out of the box. You need hot fixes. One example for this is if you use FileStream with an availability group and you use an SMB share to access it, you're out of luck. Hotfix is out now, so it works now. And we had some issues that sometimes availability groups would not come into sync after forced failover. I'm not 100% sure if this is a 2012 issue on a Windows server, but we've never seen it in Windows 2008 R2, so chances are that we're still missing something there. So it is a nice system, and I can clearly recommend it, but you have to know what you're doing if you want to run Windows 2012. So I think I made a little time for Thomas.
Okay, 1, 2, 3, mic, no mic. I turned it on, so it hopefully will switch on. Perfect. Okay, yeah, my name is Thomas Groser. I work for Bridgewater. I worked for Rick's company before, so you will see some similarity between our solutions with one big difference, that the requirements in my company start with another top priority. Our company, the top priority, Bridgewater is a hedge fund, so we are sort of like a bank, and we don't like to lose the data either. So, but our main concern is security for our data and the intellectual property around the data. That's my top priority. Then I have RTO and RPO close to zero. It doesn't have to be absolutely zero because we mostly batch-oriented operations, so we can rerun them. And we have about 1,000 databases, 200 availability groups, and about 100 servers. The biggest problem with that is, and everything runs on a virtual infrastructure, the biggest problem is our DBAs cannot access the servers for security reasons. So we had to come up with a system to completely automate everything because it takes us a substantial amount of time to actually get all the permissions to access a server. So all the bad scenarios that can come up must be pre-scripted or automated. So let's have a look at the basic infrastructure. And after the basic infrastructure, I will also explain how we did solve the problem of making replication high available, because out of the box with Microsoft, this is unfortunately not possible. And then I will talk a little bit more about the security. So, as the other guys, I need 3 data centers. In data center A, I run my primary. In data center B, I have my automatic failover replica, which is synchronous. The distance between the data centers is about 60 miles. Then I use a short data center with a file share as a witness, same as Rick did. Then I use one more local synchronous copy, which is used for offloading read-only queries on the on-site and for backups. And since I cannot have a 4th synchronous replica, I use one asynchronous. If any of them goes down, our configuration, and that's all stored in a database that's replicated to every machine, if one goes down, the other knows who has to take its role over. So if the primary goes down, it automatically fails over to the synchronous replica on the other side. But immediately after that, a script will kick in and reconfigure the system to be the primary over there and make the synchronous replica in the primary data center the new automatic failover. If the primary data center went completely down, so both are away, the same script will detect that and make the asynchronous copy in the other data center synchronous, and then make it an automatic failover. Because that has to happen in seconds, because I do not believe in single failures. Usually if something goes down, shortly thereafter more comes down. In addition to that, we misuse SQL Server in a second cluster to provide the file table storage for our transaction log backups so that they are in both data centers. So we actually back up one SQL Server's transaction logs into another SQL Server's database and have that mirrored across two sites. That's helpful. And we restore on each site to a log shipping machine, which is delayed by about an hour on purpose. This is for human errors or application errors. If an application or human does a delete statement and forgets the where clause and deletes the whole table, if we detect it within an hour, we have all the data still on the log shippers, bring them online, salvage the data out. Good. Delay log shipping, readable replicas, we went through that. How do we do the replication? We basically replicate from every system to every system because they are all connected somehow and depend on each other. So there's a lot of replication going on. The problem is, since 2008, you can make the publication highly available because you can specify a failover partner and mirroring, or in case of availability groups, it follows the virtual network name. With subscription, you can help yourself by subscribing to each node you need the data replicated to. But the problem becomes the distribution database because there is no high availability technology built in SQL Server that allows me to fail that over from one data center to another. Locally, I can put it on a cluster, on a failover cluster, and it's fine. But if I lose the whole data center, I don't have a distributor in the other data center. So what we came up is to put our distribution databases on a cluster that is built in a VI infrastructure. So basically, same thing as Amit did. And we replicate the storage, same thing as Mike did, to the other data center. In case our primary data center goes down, the virtual infrastructure just fires up the same cluster on the other side and reuses the disks. We use synchronous storage replication because, again, it's only about 60 miles. But still, this is so crawling slow compared to database mirroring and AlwaysOn availability groups that we had to split up. Every replication gets its own distribution database so that the log writes are spread out as much as possible and are not blocking each other. And each one of them has its own disk. You can imagine how our storage team likes me. If I say I need a virtual disk with a virtual server with about 100 disks attached to it, each one tiny, but yeah, they had to do it. So this is it. So now my favorite topic, security. Who thinks his data is secure on his SQL Server? Good. Very good. One guy? Yeah. Okay, he works for my company, so he knows what I do. Good. My goal when I design security is I want the same connection and security during normal operation and in HA. I've seen so many people that set up great high availability solutions, then they fail over in the other data center and haven't configured security over there, so nobody can log in into the server. Unfortunately, Microsoft doesn't take care of, you create a login on the primary server, nobody does it for you on the secondary server. So you have to put in procedures to do that, or the way we did it, we scripted it all out. We never ever create a login or anything actually directly on the server. We put it in a configuration database, kick off a job, the job goes out to all the machines, does all the work for us, and we're happy. So, what you have to ensure, this is the bare minimum, because if we wouldn't talk about that, it's about 10, 15 hours and we would not be completed. So the bare minimum, when you create logins, you must create them on every node of your availability AlwaysOn cluster. Otherwise, it's not happening if you use availability groups. Another thing that most people forget, when you create a database, you can specify which account owns the database. This is used for every stored procedure inside the database that says execute as owner. Then you run as these privileges. So when you don't specify anything, it's the account you did it with. So probably your DBA account that has sysadmin rights. That means every one of your developers has now sysadmin rights, because all he has to do is create a stored procedure that has the text execute as owner in it, and he can do anything on your machine that he wants. Okay, let me ask the question again. Who thinks his database and data is secure? Okay, now we have the opposite than before. Okay, and here it becomes from always on to almost on, because the only way to change that is to fail over the database to each node and change the setting. Because if you just change it on the primary, it gets not replicated to the other systems. So you have to fail over. Or you use my trick and execute your restore statement as the login you want the database to be owned. You have to temporarily grant it a database creator so he can restore. After that, you remove it, and the database is already owned by that account on the secondary. So when you initialize your always-on availability groups, don't use a normal restore statement. Wrap it with an exec as a low-privileged account. If and only if you need to set your database to trustworthy so that some components out of the database can actually use features of MSDB or master database, and that's a bad practice to begin with, but if you need it, it's again almost on. In this case, you have to fail over to each node and change the setting. Same thing with database chaining. Unfortunately, you can't set it in any other way. Also, if for any reason you use Active Directory delegation, constraint delegation to not let anybody use your linked servers to do whatever they want with them, you have to set these settings for each and every node. It's unfortunately we can't specify it for the whole cluster or so, and also for each SPN and listener, it has to be set on this. And outgoing linked servers, also you have to create them on each machine. That means if you have a linked server with about 500 security connections, yes, you have to recreate them on each one and type the passwords in. There's no way to script them out. And this is. So, DR tests. Who does regular DR tests? By turning off the power in his data center. Okay. We had a great idea because DR tests usually take away your availability, time, and everything. So the basic idea is to do an excellent DR test, you do it once a month, you fail over to your DR site and run next month on your DR site. And when the month is over, you fail back and run next month in your primary site again and flip all the time. This is the only way you can actually ensure. I said before, we script everything, and every time we execute a DR test, we find one tiny little bit we didn't think about. And we're playing this game for 18 months now, and it's happening and happening. And we're learning every time, and our scripts get better, but still, the only way to actually be sure that DR works is if you test it. Okay, so I have that written down on the slide too. You can read that when you go home and do your homework. And I'll almost manage to catch up the time. So we have about 5 minutes left for questions for the whole group. And
hello. Thank you. Thanks for being here. We have about 5 minutes for Q&A. What we presented to you is mission critical deployments. For what it means is that if the system goes down, the business is down. And you saw how they have gone about and designing and deploying HA and DR architecture. We'll be hanging here for more questions. And if we cannot answer any question, feel free to come by the booth and we'll definitely take them. I think there is a question at the end. Yes, sir.
let me start until you get a microphone. So when you have synchronous replication, so synchronous availability groups, then the availability group ensures a zero data loss, because everything that is committed to the client needs to be committed on both servers before the client gets the commit back. That's just the way mirroring was built and availability groups are built right now.
The other important part is you still have, if you take it 100% serious, you have to write your application in a way that if you're down to one machine, I have 4 machines, and every time one goes down, the next one takes over the synchronous mirroring. If for any reason I'm down to one machine, I'm actually signaling back to applications, guys, zero data loss is over. If you're an application requiring zero data loss, you have to stop working. It's a prioritization thing. You want zero data loss, or you want to be available. Whatever comes first in the priority, you have to go offline if you're down to one machine. Because with one machine, you just can't guarantee it. If you still have 2 running, and you can do a synchronous replication or mirroring, you're back in the game. If you can't, you have to take the application offline.
So for those of you that are doing synchronous, I'm interested in your experience across a WAN in terms of what because that transaction has to commit on both sides. What are you seeing in terms of performance and bandwidth requirements in the real world?
So this depends highly on what your application workload is like. What I see in terms of performance in my scenario is that I lose about 2 to 3 milliseconds for each transaction. The key point there is compared to a storage replication, you don't have to wait for every single write. You only have to wait for the commit. So you only lose this 3 milliseconds once every transaction. Regarding the bandwidth, there is a nice performance count on that. It means log generation rate. That tells you exactly what bandwidth you need. In my cases, we run dark fibers with a 10 gigabit infrastructure on top, so I don't have a big problem. Don't know about you.
The trick is you have to train the developers to do batched orientation work. So if you see, usually as a DBA, you can see the patterns that come in. And there's, for example, the pattern, log in, do one transaction, log out. On a synchronous mirrored system across a big distance, this is not going to work. Log in, figure out what you have to do it, send it down to one stored procedure, execute it on the server, come back with the results. Try to batch them up if possible. Then you can go almost any distance. It's, as with Rick said, it's about 1 to 2 milliseconds if you stay within a 200-mile radius and have a fast network. And then it should not matter. But if you do single operation thing, yeah, every single operation adds that 1 to 2 milliseconds.
One other thing that I would add, I'll switch over here. One other thing that I would add is that it matters a lot how you design your WAN. If you use different ISPs that are hopping all around the country or around the world before they get to the other site, that's going to introduce a lot of latency. If you structure your networks in such a way that you're using the same ISP, you have a single point of presence with that ISP in both sites or both data centers, then your latency can be minimal. But you have to really think through that as you're designing your infrastructure, or you're going to suffer from that forever.
Thank you.
Other questions?